and welcome to the fourth session of Laplace Transform lecture series. These are the contents of today's presentation. First, we will discuss inverse Laplace transform result. Then, method to find inverse is using first shifting property. Another method, inverse of functions involving logarithmic or inverse trigonometry functions. These are the results in inverse transform. First result, inverse of 1 by s is 1. Inverse Laplace transform 1 by s minus a is e raised to at. Inverse of 1 by s plus a is e raised to minus at. Inverse of 1 by s square plus a square is 1 by a sin at. Inverse of s by s square plus a square equal to cos at. Inverse of 1 by s square minus a square is 1 by a sin h at. Inverse of s by s square minus a square equal to cos h at. And inverse of 1 by s raised to n is t raised to n minus 1 by n minus 1 factorial when n is a positive integer. And these results are mainly classified according to the denominator of the given expression. Is summarized in the next slide. There are 6 options. If denominator is s, we have to use the result inverse Laplace transform 1 by s equal to 1. If denominator is s raised to n, then we had to use the result inverse of 1 by s raised to n equal to t raised to n minus 1 by n minus 1 factorial when n is a positive integer. If denominator is s minus a, we have to use the result inverse of 1 by s minus a equal to e raised to at. If denominator is s plus a, then we have to use the result inverse Laplace transform 1 by s plus a equal to e raised to minus at. If denominator is s square plus a square, then there are 2 options according to the numerator. If numerator is 1, then we have to use the result inverse of 1 by s square plus a square equal to 1 by a sin at. And if numerator is s, we have to use inverse of s by s square plus a square equal to cos at minus a square. In this case also, we have 2 options according to the numerator. First result is inverse of 1 by a square minus a square is 1 by a sin h at, or we had to use the second result inverse of s by s square minus a square equal to cos h at. So inverse Laplace transform problems are classified according to the denominator of the given question. Now we move on to next session. Inverse using first shifting property. First result is inverse Laplace transform of f of s minus a is equal to e raised to at into inverse of f of s. Second one, inverse Laplace transform of f of s plus a is equal to e raised to minus at into inverse of f of s. That is, if a function is of the form f of s minus a or f of s plus a, we had to use the concept of inverse using first shifting property. To eliminate the effect of minus a, or if the function is f of s minus a, then to find the inverse, to eliminate the effect of minus a, we have to multiply by e raised to at. If the function is f of s plus a, to eliminate the effect of plus a, we have to multiply by e raised to minus 8. Now we move on to problems. First problem, find inverse Laplace transform of 1 by s square plus 2s plus 2. In inverse Laplace transform question, first we have to look into the denominator of the given question. And in this case, denominator, it is of second degree. So first we have to check whether it is factorizable or not. If it is factorizable, then we can apply partial fraction technique to find the inverse Laplace transform. But in this case, the denominator is not factorizable in terms of real factors. So in such cases, we have to apply the method of completing squares. So here we add and subtract the square of the coefficient of half of the coefficient of s. Here coefficient of s is 2, half is 1. So we have to add 1 square and compensate, we have to subtract 1 square. And consider first 3 terms is of the form a square plus 2ab plus b square, which reduces to a plus b whole square. So s square plus 2s plus 1 square becomes s plus 1 whole square minus 1 plus 2 becomes plus 1, or it can be written as square s plus 1 whole square plus 1 square. Therefore, 1 by s square plus 2s plus 2 is equal to 1 by s plus 1 whole square plus 1 square. Now we can find inverse Laplace transform. Taking inverse on both sides, we obtain inverse Laplace transform of 1 by s square plus 2s plus 2 is equal to inverse of 1 by s plus 1 whole square plus 1 square. In this case, the expression, it is a function of s plus 1. If the expression is f of s plus a or f of s minus a, we had to use the concept of inverse using first shifting property. So here the expression is a function of s plus 1. So to eliminate the effect of this plus 1, we had to multiply by e raised to minus t. So then it becomes e raised to minus t into inverse Laplace transform of 1 by s square plus 1. By multiplying by e raised to minus t, this plus 1 cancels. Or to eliminate the effect of this plus 1, we multiply by e raised to minus t. So this becomes e raised to minus t into inverse transform of 1 by s square plus 1 square. Is equal to e raised to minus t into 1 by 1 sin t, because inverse of 1 by a square plus a square equal to 1 by a sin a t. In this case, a equal to 1. Final answer is e raised to minus t into sin t. So to complete this problem, we apply inverse using first shifting property. Second question, find inverse Laplace transform of s by s square plus 4s plus 5. Case also, first consider the denominator is of second degree and it is not factorizable also. We had to apply method of completing squares. In this case, coefficient of s is 4. It's at then first 3 times it becomes s plus 2 whole square, constant becomes plus 1 is equal to s plus 2 whole square plus 1 square. Then we can write s by s square plus 4s plus 5 as s by s plus 2 the whole square plus 1 square. We can find the inverse Laplace transform. Again, we had to note one more point. We always look into the denominator of the expression. In this case, denominator is a function of s plus 2. Also, numerator contains the variable s. So we have to convert this s in terms of s plus 2. S can be written as s plus 2 minus 2. Then s divided by s square plus 4s plus 5. It becomes s plus 2 minus 2 all divided by s plus 2 whole square plus 1 square. Now we can find inverse. Taking inverse on both sides, we obtain inverse Laplace transform of s by s square plus 4s plus 5 equal to inverse of s plus 2 minus 2 all divided by s plus 2 the whole square plus 1 square. Now consider the RHS. This is an expression of s plus 2. So to find inverse, we have to apply inverse using first shifting property. To eliminate the effect of plus 2, we have to multiply by e raised to minus 2t. So RHS becomes e raised to minus 2t to inverse of s minus 2 divided by s square plus 1 square. We can consider the denominator of the RHS expression is s square plus 1 square. Is of the form s square plus a square. Then we have two options. Numerator can be 1 or s. So here there is a term of s and a constant minus 2. So we can take the expression as like this. E raised to minus 2t into inverse of s by s square plus 1 square minus 2 into inverse of 1 by s square plus 1 square. We can find its inverse directly. First one is of the form inverse of s by s square plus s square is sin 80 and is 1. So inverse is cos t minus 2 into inverse of 1 by s square plus s square is 1 by a sin e. In this case a is 1, it becomes 1 by 1 sin t. The final answer is e raised to minus 2t to cos t minus sin t. Next problem, find inverse Laplace transform of 5s plus 3 all divided by s minus 1 into s square plus 2s plus 5. Here also we first look into the denominator. In this case, denominator is a product of two terms. If denominator is product of two or more terms, first we have to apply partial fraction technique. So this is the partial fraction form a by s minus 1 plus bs plus c divided by s square plus 2s plus 5. In this case, we can find the value of a using shortcut method. Value of b and c can be found by the general method or conventional method. To find the value of a, we have to substitute s equal to 1 in the LHS except the factor s minus 1. S equal to 1, it is obtained by substituting denominator a, denominator of a with 0. Denominator of a is minus 1, it is equated to 0, means we get s equal to 1. To find the value of a, we have to substitute s equal to 1 in the LHS except the factor s minus 1. So we obtain a equal to 5 into 1 plus 3 divided by 1 square plus 2 into 1 plus 5 reduces to. Now to find b and c, we have to apply the general method. For that, First we multiply both sides by s minus 1 into s square plus 2s plus 5. So we obtain 5s plus 3 equal to a into s square plus 2s plus 5 plus bs plus c into s minus 1. Now open the bracket, obtain the expression this. We equate coefficients of s square on both sides. The LHS, there is no time with the s square, so its coefficient is 0. RHS, there are two terms, a plus b. So we have a plus b equal to 0. We already find the value of a equal to 1. It gives b equal to minus 1. We equate constants on both sides. From this relation, we obtain the value of c as 2. Now substituting these values, we get 5s plus 3 followed by s minus 1 to s square plus 2s plus 5 equal to 1 by s minus 1 plus minus 1 into s plus 2 followed by s square plus 2s plus 5. The second time we can take minus outside. So we get the expression as equation 2. Now consider the denominator of the second term in equation 2, which is of second degree and which is not factorizable also. So we have to proceed like above problem. We have to convert this expression into a square format by method of completing squares. By method of completing squares, we obtain s square plus 2s plus 5 equal to s plus 1 the whole square plus 4, or equal to s plus 1 whole square plus 2 square. Therefore, the second term can be written as s minus 2 divided by denominator changes to s plus 1 whole square plus 2 square. Again, look the denominator of the expression. Here denominator is a function of s plus 1. Numerator contains the variable s. So here we had to convert this s in terms of s plus 1. S can be written as s plus 1 minus 1. We substitute these values in equation 2. It becomes 5s plus 3 followed by s minus 1 into s square plus 2s plus 5 is equal to 1 by s minus 1 minus of s plus 1 minus 3 followed by s plus 1 whole square plus 2 square. Now we can find inverse Laplace transform. Taking inverse on both sides, we obtain expression like this. Here we can apply the linearity property. It becomes inverse of 1 by s minus 1 minus inverse of s plus 1 minus 3 followed by s plus 1 whole square plus. Consider the second expression. Second expression is a function of s plus 1. To eliminate the effect of this plus 1, we have to multiply by e raised to minus t. This becomes inverse of 1 by s minus 1 is e raised to t minus e raised to minus t into. This e raised to minus t is for eliminating this plus 1 into inverse of s minus 3 followed by square plus 2 square. Again consider the denominator is s square plus 2 square, or it is of the form s square plus a square. We can have two options. Numerator can be 1 or s. In this case, numerator contains the variable s and a constant time. So we split the expression. By splitting, we get e raised to t minus e raised to minus t into inverse of s by s square plus 2 square minus 3 into inverse of 1 by s square plus 2 square. Now we can find inverse directly. Answer is e raised to t, e raised to minus t into inverse of s by s square plus 2 square is cos 2t. Inverse of 1 by s square plus 2 square is 1 by 2 sin 2t. The final answer. Now we move on to next problem.
സാറേ കുറച്ച് ക്വസ്റ്റ്യൻസ് ഉണ്ട്, നമുക്കത് എടുത്താലോ?
ഓക്കെ, ആയിക്കോട്ടെ.
ഓക്കെ സാറ്, നമുക്ക് ആക്ച്വലി കഴിഞ്ഞ സെഷനിലെ ക്വസ്റ്റ്യൻസും രണ്ടു മൂന്ന് പേര് ചോദിച്ചിട്ടുണ്ട്. അത് നമുക്ക് ലാസ്റ്റ് എടുത്താൽ പോരെ? ഇതിന്റെ കഴിഞ്ഞിട്ട് ലാസ്റ്റ് സമയം ഉണ്ടെങ്കിൽ അത് ചോദിക്കാം.
ആയിക്കോട്ടെ.
ഓക്കെ സാർ, അപ്പൊ ഇപ്പൊ നമുക്ക് വന്നേക്കുന്ന സാർ ക്വസ്റ്റ്യൻ നമ്പർ 2ഉം 3ഉം ഒന്നും കൂടെ എക്സ്പ്ലെയിൻ ചെയ്യാമോ എന്ന് പറഞ്ഞ് കുറച്ചധികം പേര് ചോദിച്ചിട്ടുണ്ട്. ഒന്നും കൂടെ പറയാമോ എന്ന്? ക്വസ്റ്റ്യൻ നമ്പർ 2ഉം ക്വസ്റ്റ്യൻ നമ്പർ 3ഉം. ഓക്കെ സാറേ.
Consider second question. Find inverse Laplace transform of any question. We have to consider the denominator of the expression. In this case, denominator is s square plus 4s plus 5. It is of second degree. If the denominator is a second degree term, first check whether it can be factorizable or not. In this case, the expression is not factorizable in terms of real expressions. So we have to go for another method. We apply method of completing squares. For method of completing squares, we have to add and subtract square of half of the coefficient of s. In this case, coefficient of s is 4, half is 2. So we add 2 square and subtract 2 square. Now consider the first 3 terms. S square plus 4s plus 2 square. This is of form s square plus 2ab plus b square is a plus b whole square. So the term in the bracket can be written as s plus 2 the whole square minus 4 plus 5, it becomes plus 1. 1 can be written as 1 square. So s square plus 4s plus 5 is equal to s plus 2 the whole square plus 1 square. So denominator can be changed as s plus 2 whole square plus 1 square. That is s by s square plus 4s plus 5 is equal to s by s plus 2 the whole square plus 1 square. Now we can find inverse Laplace by taking L inverse on both sides. Again, one more condition we have to note. In this case, the denominator is a function of s plus 2 and the numerator contains the variable s. So to apply the concept of inverse using shifting property, the whole function must be of the form f of s plus a or a function of s minus a. Here denominator is s plus 2. So s in the numerator also must be converted into s plus 2. So first we convert s into s plus 2. So it can be written as s equal to s plus 2 minus 2. Therefore s by s square plus 4s plus 5 is equal to s plus 2 minus 2 followed by s plus 2 the whole square plus 1 square. Now we can find inverse directly. Taking L inverse on both sides, get the expression like this, and consider the RHS. RHS totally is a function of s plus 2, or it is generally of the form f of s plus a. To eliminate the effect of plus a, we had to multiply by e raised to minus 80. In this case, this expression is function of s plus 2. So to eliminate the effect of this plus 2, we have to multiply by to eliminate the effect of this plus 2, we have to multiply the whole expression by e raised to minus 2t. By multiplying by e raised to minus 2t, this plus 2 cancels. It becomes e raised to minus 2t into inverse of s minus 2 followed by s square plus 1 square. Now denominator is s square plus 1 square, or it is of the form s square plus a square. So we have two options. Numerator may be 1 or s. So we have to split this expression. We split the expression as s by s square plus 1 square minus 2 into inverse of 1 by s square plus 1 square. Now we can find inverse directly. Is e raised to minus 2t into cos t minus 2 into 1 by 1 sin t. This is the final answer. Now third question. Find inverse of 5s plus 3 followed by s minus 1 into s square plus 2s plus 5. First we look into the denominator. In this case, the denominator is a product of two terms, in which one term is of first degree and the second term is of second degree. This second degree term, it cannot be factorized in terms of real terms. So first we had to apply partial fraction, and this is the partial fraction. And some coefficients can be found by shortcut method. Non-repeated first degree coefficients of non-repeated first degree terms can be directly found by shortcut method. So here s minus 1 is a non-repeated first degree term. So we can find the value of a using shortcut method. B and C are coefficients corresponding to a second degree term, which cannot be found using shortcut method. To find a, we have to substitute s equal to 1. S equal to 1 is obtained by substituting denominator of a with 0. Denominator of a is s minus 1 equated to 0, means we obtain value of s equal to 1. And this value of s equal to 1 is substituted in the LHS except the factor s minus 1. So here s is replaced by 1, here is s is replaced by 1, here also we replace by 1. So we obtain value of a equal to 8 divided by 8 alone. To find b and c, we have to apply the conventional method or general method. For that we have to multiply by the denominator. Denominator is s minus 1 into s square plus 2s plus 5. We get the expression like this. To find the remaining coefficients, we had to equate coefficients of corresponding degree term. So first equate coefficients of s square. Equating coefficients of s square, the LHS there is no term with s square. Coefficient is 0. The RHS there are two terms, a plus b. So coefficient is a plus b. We already obtained the value of a equal to 1. So use b equal to 1. We equate constants. Equating constants, we obtain the expression as 3 equal to 5a minus 3 gives b equal to 2. Now substitute the values of a, b and c in equation 1. So we obtain the expression like this. Now consider this equation 2. Inverse of first expression can be directly found. Consider the second expression. Here denominator is a second degree term which does not belong to the standard format. It's not factorizable also. So we have to apply the format like last problem. First we have to convert this expression into a square format by applying method of completing squares. So here we apply method of completing squares. It becomes s plus 1 whole square plus 2 square. So s minus 2 by s square plus 4s plus 5, which is equal to s minus 2 divided by s plus 1 whole square plus 2 square. Again consider the denominator. Denominator is a function of s plus 1 and the numerator contains the variable s. So we have to convert this s into s plus 1. So s minus 2 becomes s plus 1 minus 3. Values are substituted in equation 2. Now we can find inverse directly. So inverse of the question equal to inverse of 1 by s minus 1 minus of s plus 1 minus 3 followed by s plus 1 whole square plus 2 square. Here we apply the linearity property. And inverse of first one can be directly obtained. Inverse of 1 by s minus a is e raised to at. Here a equal to 1. Consider a second expression. This is a function of s plus 1. So to eliminate the effect of this plus 1, we have to multiply this expression by e raised to minus. So by multiplying by e raised to minus t, this plus 1 cancels. It becomes e raised to t minus e raised to minus t into inverse of s minus 3 divided by s square plus 2 square. Again consider the denominator is s square plus a square form. So we had to split the expression again. Now we can find inverse directly. I think the doubt is clear.
Yes, sir. So, sir, random follow-up questions on under. In third question, 5s plus 3 is converted to a plus bs plus c. That എങ്ങനെയാണെന്ന് ചോദിക്കുന്നുണ്ട്.
Third question. This is by partial fraction. Here
Okay, sir.
We apply partial fraction.
Sir, അതിൽ തന്നെ can we use this completing square method for all factorizable denominators എന്ന് പറഞ്ഞൊരു question ചോദിച്ചിട്ടുണ്ട്.
It is also possible.
Okay, sir.
Factorize ചെയ്യാൻ പറ്റുന്ന പ്രോബ്ലത്തിലും ഈ മെത്തേഡ് യൂസ് ചെയ്യാം. സെയിം ആൻസർ ആയിരിക്കും കിട്ടും.
Okay. ഒരു question കൂടെ. Sir, how can we know whether it is factorizable or not? Question by Archa Gopan.
That is a basic concept for the solution of equations.
Okay, sir. അപ്പോൾ നമുക്ക് കണ്ടിന്യൂ ചെയ്താലോ സർ? ആയി അടുത്ത സെറ്റ് ഓഫ് ക്വസ്റ്റ്യൻസ് അത് കഴിഞ്ഞിട്ട് എടുക്കാനോ?
ഓക്കെ ആയിക്കോട്ടെ.
ഓക്കെ സർ, താങ്ക് യു.
Now consider the fourth question. Find inverse Laplace transform of s square by s minus 2 whole cube. In this case also, first consider the denominator is s minus 2 whole cube. It is a repeated factor of s minus 2. So denominator is a repeated factor or product of two or more terms, first we have to apply partial fraction. We can write s square divided by s minus 2 whole cube. Its partial fraction form is a by s minus 2 plus b by s minus 2 whole square plus c by s minus 2 whole cube. And in this case, we can find the coefficient c using shortcut method. If denominator is a repeated factor of first degree term, then we can find the coefficient of highest power can be found by using shortcut method. Other coefficients, to find other coefficients, we have to apply the general method. So in this case, we can find only c by using the shortcut method. For that, we have to substitute s equal to 2 in the LHS, except the factor s minus 2 the whole cube. So here we substitute s equal to 2 except the factor s minus 3 whole cube. So you obtain value of a equal to 2 square is equal to 4. To find a and b, we have to apply the general method. For that, we have to multiply both sides by s minus 2 the whole cube. So it becomes s square equal to a into s minus 2 the whole square plus b into s minus 2 plus c. If I open the bracket, we obtain the expression like this. We equate coefficients of s square on both sides. So we get the LHS coefficient of s square is 1, the RHS coefficient of s square is a. So we have the value of a equal to 1. Equate the coefficients of s on both sides. We get 0 equal to, because there is no term of s, so its coefficient is 0, equal to minus 4a plus b. Gives b equal to 4a, 4, because a equal to 4. So we obtain the value of a, b, c already we find. Substitute these values. Equation 1, we get s square by s minus 2 whole cube equal to 1 by s minus 2 plus 4 by s minus 2 whole square plus 4 by s minus 2 whole cube. Now we can find inverse directly. Take inverse on both sides. Then apply the linearity property. Consider the first one. Inverse of 1 by s minus 2 is e raised to. Consider the second one. This denominator is s minus 2 whole square. So first we have to eliminate the effect of minus 2. To eliminate the effect of this minus 2, we have to multiply by e raised to 2t. So your second term becomes e raised to 2t into, by multiplying by e raised to 2t, this minus 2 cancels. The same procedure can be applied for the last expression. To eliminate this minus 2, we have to multiply this expression by e raised to 2. So it becomes e raised to 2t plus 4 into e raised to 2t into inverse of 1 by s square plus 4 into e raised to 2t into inverse of 1 by s cube. And the second and the third one, they are of the form inverse of 1 by s raised to n. Inverse of 1 by s raised to n is e raised to n minus 1 by n minus 1 factorial. By applying this result, you obtain the final answer as e raised to 2t plus 4 into e raised to 2t into t plus 4 into e raised to 2t into square by. One, find inverse Laplace transform of 4s plus 5 all divided by s minus 1 the whole square to s plus 2. In this case also, first consider the denominator of the expression is the product of two terms. So first we apply partial fraction. Partial fraction form is a by s minus 1 plus b by s minus 1 square plus c by s plus 2. And here s minus 1 is a repeated factor. It repeat 2 times. So its maximum expression is s minus 2 whole square. Its coefficient is b. So we can find b by shortcut method. Also, c is the coefficient of 1 by s plus 2. It is a non-repeated first degree term. So c also can be found using shortcut method. So here we can find the values of b and c by using shortcut method. To find b, we have to substitute s equal to 1 except the factor s minus 1 whole square. So here we have to substitute s equal to 1, here also 1. So 9 by 3 gives 3. Value of b is 3. And to find c, we have to substitute s equal to minus 2 except the factor plus 2. Use c equal to minus 1. We have to find the value of a also. To find the value of a, we have to apply the general method. For that, we have to multiply both sides by this denominator. We get 4s plus 5 is equal to a into s minus 1 into s plus 2 plus b into s plus 2 plus c into minus 1 whole square. By expanding the expression, we obtain the expression like this. We equate coefficients of s square on both sides. We have 0 equal to a plus c. Therefore, a equal to minus c. We already find the value of c. So, we have the value of a equal to 1 by 3. Now, we have the values of a, b, and c, which can be substituted in equation 1. Substituting in equation 1, we obtain the expression as 1 by 3 by s minus 1 plus 3 by s minus 1 whole square plus minus 1 by 3 divided by. Now we can find its inverse Laplace transform. Taking inverse on both sides, we obtain the expression like this. The RHS, we can apply the linearity property. So constants can be taken outside and we can split the corresponding terms. And for the first one, we can find inverse directly. For the second one, we have to apply the concept of inverse using first shifting property. That is, to eliminate the effect of this plus 1, we have to multiply the whole expression second time by e raised to second time. If we multiply by second time by e raised to t, then this plus 1 cancels. So we obtain the expression like this. Final answer is the second one. Inverse of 1 by s square is e raised to 2 minus 1 by 2 minus 1. Final answer is 1 by 3 e raised to t plus 3 into e raised to t into t by 3 into raised to minus 2. We move on to another question. Find inverse Laplace transform of s divided by s minus 3 into s square plus 4. In this case also, denominator is a product of 2 times, in which one time is first degree, the second expression is of second degree, which is not factorizable. So first we apply partial fraction. This is the partial fraction form. A by s minus 3 plus bs plus c divided by square plus 4. Here we can find the value of a by shortcut method, because a is the coefficient of a non-repeated first degree term. B and C correspond to a second degree expression. So we had to find B and C by the general method. And to find A, we had to substitute S equal to 3 in the LHS, except the factor s minus 3. So here we had to substitute S equal to 3 also. The value of A is by 13. To find B and C, we had to multiply the equation 1 by the denominator s minus 3 into s square plus 4. So we obtain expression like this. We open the bracket, get s equal to expression. Now equate coefficients of s square on both sides. There is no term in LHS, no term of s square in LHS, so its coefficient is 0. There are two terms of s square in the RHS, so coefficient is a plus b equal to minus a, value of b is. Now equating constants, get 0 equal to 4a minus 3c. From this relation, have c equal to 4 by. We have the values of a, b and c. Can be substituted in equation 1. So equation 1 becomes s by s minus 3 to s square plus 4 equal to expression in the RHS. Now we can find inverse directly. Take inverse on both sides. Here we can apply the linearity problem. Take constants outside. We can split the corresponding term. 3 by 13 into inverse of s minus 3, 1 by s minus 3 minus 3 by 13 into L inverse of s by s square plus 2 square plus 4 by 13 into L inverse of 1 by s square plus 2 square. Inverse of 1 by s minus 3 is e raised to 3t. Inverse of s by s square plus a square is cos at, and in this case a equal to 2. And for the last time, we have to apply the result inverse of 1 by a square plus a square is 1 by a sin a. Here equal to, this is the one more question. Find inverse Laplace transform of 1 by s cube minus a. Consider the denominator. In case it is a third degree term. We have the general result only for first degree expression and second degree expression. Here the denominator is a third degree term. So a third degree expression can be factorizable in terms of a first degree term and a second degree term. You can always factorize a third degree expression in terms of a first degree term and a second degree term. We have the result a cube minus b cube equal to a minus b into a square plus ab plus b square. So applying this result, we can write value of s cube minus a cube as s minus a into a square plus as plus a square. Therefore, 1 by s cube minus a cube, it can be written as 1 by s minus a into a square plus as plus a square. Now consider the RHS term. Here the denominator is a product of two terms. If denominator is a product of two or more terms, we have to apply partial fraction. This is the partial fraction form. A by s minus a plus bs plus c divided by a square plus as plus a square. And here capital A, it is the coefficient of 1 by s minus a, or it is the coefficient corresponding to non-repeated first degree term. So we can find a using shortcut method. To find the value of capital A, we had to substitute S equal to A in the LHS except the factor. So here S is replaced by A. Here also S is replaced by A. So we have capital A equal to 1 by A square plus A into A square plus A square. Capital A is 1 by 3 square. To find B and C, we had to apply the general method. For that, we had to multiply both sides by this denominator. We obtain 1 is equal to A into A square plus AS plus A square plus BS plus C to S minus A. Open the bracket. We obtain the expression like this. We equate coefficients of A square on both sides. We obtain 0 equal to A plus C. 0 equal to A plus B. E. So we have B equal to minus A. Value of A is 1 by 3 A square. So we obtain capital B equal to minus 1 by. Equating constants, we obtain 1 equal to capital A into A square minus. From this relation, we can find the value of C. So we obtain C equal to minus 2 by 3A. Now we have the values of capital A, B and C can be substituted in equation 1. So equation 1 becomes 1 by 3A square divided by S minus A plus minus 1 by 3A square into S minus 2 by 3A divided by A square plus AS plus A square. From the second term, we can take minus 1 by 3A square outside. It becomes 1 by 3A square into 1 by S. 1 by 3A square into becomes S plus 2A followed by A square plus AS plus A square. Consider the second term. Denominator of the second term is a second degree expression which cannot be factorizable. So we have to apply method of completing squares. Here we have to add and subtract square of A by 2. So this becomes A square plus AS plus A by 2 the whole square minus A by 2 whole square plus A square. Consider the first 3 terms. This will form A plus B whole square. First 3 terms can be written as S plus A by 2 whole square. The constant part reduces to, this expression is A square by 4 minus A square by 4 plus A square becomes 3A square by 4. Now this 3A square by 4 can be written as root 3 into A by 2 the whole square. So the second term is written as, again we have to note that the denominator is a function of S plus A by 2. So this S in the numerator must be converted into S plus A by 2. So this is written as S plus A by 2 as A by 2 plus 2. It reduces to S plus A by 2 plus 3A by 2 followed by, denominator can be replaced by S plus A by 2 whole square plus root 3A by 2 whole square. Consider this expression. This is a function of S plus A by 2. Find inverse of this expression. You can apply the concept using first shifting property. Taking inverse, you obtain the expression like this. We apply the linearity property. You can take constant outside and you can split the corresponding terms. It becomes 1 by 3a square inverse of 1 by s minus a minus 1 by 3a square into inverse of s plus a by 2 plus 3a by 2 whole divided by s plus a by 2 whole square plus root 3a by 2 whole square. The inverse of first term can be directly obtained of the form inverse of 1 by s plus a. It is e raised to 80. To find the inverse of the second term, we had to apply the concept using first shifting property. This expression is a function of s plus a by 2. So to eliminate the effect of this plus a by 2, we had to multiply the whole expression by e raised to minus a by 2 by 2 So by multiplying by e raised to minus a by 2t, this plus a by 2 cancels. It becomes, second term becomes 1 by 3a square e raised to minus a by 2t inverse of s plus 3a by 2 divided by s square plus root 3a by 2 the whole square. Now denominator is of the form s square plus a square. Then we have two options. Numerator may be s or 1. So we split this expression. This is common for these two terms. We can find inverse directly. First one is of the form inverse of s by a square plus a square. It is cos 80. Here value of a is root 3 a by 2. Second one is of the form inverse of 1 by a square plus a square. It is 1 by a sin 8. By taking inverse, you obtain the rest. This reduces to 1 by 3a square into e raised to 80 as 1 by 3a square into e raised to minus a by 2t cos root 3 a by 2t plus root 3 into sin root 3 a by 2. So for this question, denominator was of third degree. So first we factorize and then apply partial fraction. Now moving on to problem. Find inverse Laplace transform of 4s divided by x raised to 4 plus 4. In this case also, first consider the denominator is s raised to 4 plus 4. Is of fourth degree. If denominator is, if the degree of denominator is 3 or more, we have to apply some another method to factorize the corresponding term. So first consider the denominator. Denominator can be written as s raised to 4 plus 4 equal to s square the whole square plus 4 can be written as 2 square. Now this is of the form a square plus b square. A square plus b square can be written as a plus b the whole square minus 2ab. Here a is a square and b is 2. This becomes a square plus 2 the whole square minus 2 into a square into 2. It reduces to a square plus 2 the whole square minus 2 into 2 4 square. 4 square is as 2s the whole square. Again we had to rearrange this expression. This is of form a square minus b square. A square minus b square can be written as a plus b into a minus b. So this expression becomes a square plus 2 plus 2s to a square plus 2 minus 2s. Using a square minus b square equal to a plus b into a minus. It can be written as a square plus 2s plus 2 into a square minus 2s plus 2. So the denominator s raised to 4 plus 4 is factorized as a square plus 2s plus 2 into a square minus 2s plus So denominator becomes product of two terms, and consider terms. These terms are not factorizable. So first we apply partial fraction technique. The partial fraction form is as plus b divided by s square plus 2s plus 2 plus cs plus d divided by s square minus 2s plus 2. And here the coefficients a, b, c and d corresponds to second degree terms. We cannot find these values using shorter method. Find the values of a, b, c and d. We have to apply the general method. That we have to multiply by the denominator. Multiplying by denominator, it becomes 4s equal to as plus b into s square minus 2s plus 2 plus cs plus d into s square plus 2s plus 2. We can open this bracket. And equating coefficients of corresponding degree terms. First we equate the coefficients of s cube. We have the result 0 equal to a plus b. Mark it as equation 2. And equate the coefficients of square. We obtain 0 equal to minus 2a plus b plus 2c plus d. That's equation 3. Equate coefficients of s. Get the expression as equation 4. Finally equate constants. We obtain 0 equal to 2b plus equation 5. We had to solve equations 2, 3, 4 and 5 to find the values of a, b, c. By solving corresponding equations, we get value of a equal to 0, b equal to minus 1, c equal to 0 and d equal to 1. We can substitute these values in equation 1. Equation 1 reduces to 4s divided by s raised to 4 plus 4 equal to 1 by s square plus 2s plus 2 plus 1 by s square minus 2s plus 2. Now consider the denominator of the RHS term. It is not factorizable. So we have to apply method of completing square for these two terms. So s square plus 2s plus 2 can be written as s plus 1 whole square plus 1 square. S square minus 2s plus 2 can be written as s minus 1 whole square plus 1 square. Substitute these values to obtain the expression like this. Now we can find inverse Laplace transform. So inverse of the given quotient equal to inverse of the expression. Here we apply the linearity property. Here to find inverse, we can apply the concept of inverse using shifting property. To eliminate the effect of plus 1, we have to multiply the first term by e raised to t. And to eliminate the effect of this minus 1, we have to multiply the second term by e raised to t. So it becomes e raised to t into inverse of 1 by s square plus 1 square plus e raised to t. For the first term we have to multiply by e raised to minus t plus second term e raised to t into inverse of 1 by s square plus 1 square. The final answer is minus e raised to minus t into 1 by 1 sin plus e raised to t 1 by 1 sin. Take sin t outside. Final answer is t into e raised to t plus e minus. Any questions?
ഹലോ സർ, ക്വസ്റ്റ്യൻസ് ഉണ്ട്. അപ്പോ സാർ നമ്മൾ അടുത്ത ടോപ്പിക്കിലേക്ക് പോവാൻ സമയം കിട്ടുമെന്ന് എനിക്ക് തോന്നുന്നില്ല, കാരണം കുറച്ചധികം ക്വസ്റ്റ്യൻസ് ഉണ്ടായിരുന്നു. ഒറ്റ മിനിറ്റ് സാറേ, ക്വസ്റ്റ്യൻസ്
ചോദിച്ചോളൂ.
ഓക്കെ സാർ, കാരണം സമയം പ്രശ്നമാണല്ലോ. സാർ ഒരു ക്വസ്റ്റ്യൻ ക്വസ്റ്റ്യൻ നമ്പർ 4 നമിത ബാസ്റ്റിന്റെ ക്വസ്റ്റ്യൻ ആണ് ഹൗ ടു ഫൈൻഡ് വാല്യൂസ് ഓഫ് എ ബി സി ഇൻ ക്വസ്റ്റ്യൻ നമ്പർ 4.
A, B, C in question number 4.
അതെ.
In question number 4, we can find the values of A, B, and C. This can be done by.
സർ ഒരു ഒറ്റ റിക്വസ്റ്റും കൂടെ സർ, മൈക്ക് ഒന്ന് കുറച്ചുകൂടെ അടുത്ത് പിടിച്ച് സംസാരിക്കാമോ? എനിക്ക് കേൾക്കുന്നുണ്ട്, പക്ഷേ നമ്മുടെ പാനൽ മറ്റേ അറ്റൻഡീസിൽ കുറച്ചുപേര് കേൾക്കണില്ല എന്ന് പറഞ്ഞ് മെസ്സേജ് അയക്കുന്നുണ്ട്.
Okay.
Okay, sir. Thank you.
Now consider the question 4. Its partial fraction form is A by s minus 2 plus B by s minus 2 square plus C by s minus 2 whole cube. And in this case, the denominator, it is a repeated factor of s minus 2. If denominator is a repeated factor of s minus 2, we can find the maximum repeated coefficient using shortcut method. And other coefficients can be found by the general method. Here C correspond to maximum power of s minus 2. So we can find C using shortcut method. A and B can be found by the general method. Next question.
ഹലോ സർ, കേൾക്കാമോ?
കേൾക്കാം. നെക്സ്റ്റ് ക്വസ്റ്റ്യൻ.
സർ, ഇപ്പൊ സാർ പറഞ്ഞ ആക്ച്വലി കുറച്ച് ബ്രേക്ക് ഉണ്ടായിരുന്നു. എനിക്ക് ഇത്ര നേരം പ്രശ്നമായി, ഇപ്പൊ ഒന്ന് ബ്രേക്ക് ആവുന്നത് പോലെ കേൾക്കുന്നുണ്ടായിരുന്നു. ഒന്നും കൂടെ ജസ്റ്റ് ഒന്ന് പറയാമോ ആ ക്വസ്റ്റ്യൻ? കാരണം കുറച്ച് ബ്രേക്ക് ഉള്ളതുകൊണ്ടാ.
ഓക്കെ, പറയാം. നോ പ്രോബ്ലം. This is the partial fraction form.
ഇല്ല സാർ, ഇപ്പോഴും നല്ലപോലെ ബ്രേക്ക് ആവുന്നുണ്ട്.
കേൾക്കാവുണ്ടോ?
ഇപ്പൊ കേൾക്കാമായിരുന്നു.
ഇപ്പൊ കേൾക്കാവോ?
ഇപ്പൊ ബെറ്റർ ആണ് സാർ.
ബെറ്റർ ആണല്ലേ? ഓക്കെ.
Okay.
This is the corresponding partial fraction form, and here denominator is a repeated factor of s minus 2. It is a first degree term. If denominator is a repeated factor of first degree term, then you can find the coefficient of highest power by shortcut method, and in this case coefficient of highest power is c. So we can find value of c only by using the shortcut method. A and B can be found by the general method. To find the c, we have to substitute s equal to 2 in the LHS, except the factor s minus 2 whole cube. So here, to find c, we substitute s equal to 2 except s minus 2 whole cube. So c equal to 2 square equal to B and C can be found by using the general method. Next problem.
സർ, ക്വസ്റ്റ്യൻ നമ്പർ 4 തന്നെയാണ്. ലാസ്റ്റ് പാർട്ട് ഒന്നും കൂടെ പറയാമോ എന്ന് പറഞ്ഞ് ആർച്ച ഗോപൻ ചോദിച്ചു, അദ്വൈത് രാജീവ് ചോദിച്ചിട്ടുണ്ട്. ലാസ്റ്റ് പാർട്ട് ഫോർത്ത് ക്വസ്റ്റ്യൻ.
Okay. By substituting the values of A, B, and C, we obtain the expression like this. Now we can find inverse directly. So inverse of 1 by s minus.
ഇപ്പൊ വീണ്ടും ബ്രേക്ക് ആവുന്നുണ്ട് സർ. കുറച്ചും കൂടെ ഒന്ന് മൈക്ക്, നെറ്റ് ഇഷ്യൂ ഇല്ലല്ലോ അല്ലേ അവിടെ?
നെറ്റിന്റെ ഇഷ്യൂ ഉണ്ടാവാൻ സാധ്യതയില്ല.
ഇപ്പൊ വ്യക്തമായി കേൾക്കാം സർ. ഇപ്പൊ വ്യക്തമായി കേൾക്കാം
അല്ലേ? ഓക്കെ. So here we can apply the linearity property. To find inverse of this expression, for the first term inverse can be directly found because it is of the form inverse of 1 by s minus a, here a equal to 2, so its inverse is e raised to 2t. Now consider the second expression. To eliminate the effect of this minus 2, we had to multiply second term by e raised to by multiplying by e raised
സർ വീണ്ടും ബ്രേക്ക് ആവുന്നുണ്ട് സർ, ഭയങ്കരമായിട്ട് നല്ലപോലെ ബ്രേക്ക് ആവുന്നുണ്ട്, കേൾക്കണില്ല. മെസ്സേജും പിള്ളേർ മെസ്സേജ് അയക്കുന്നുണ്ട്, കാണ്ട് ഹിയർ യു സർ എന്ന് പറഞ്ഞിട്ട്. സർ ഇടയ്ക്കൊന്ന് കേട്ടായിരുന്നു, അത് ഇപ്പൊ വീണ്ടും പോയതാ.
ഇപ്പൊ കേൾക്കുന്നുണ്ടോ?
ഇപ്പൊ കേൾക്കാം സർ. ഹലോ,
കണ്ടിന്യൂ ചെയ്തോട്ടെ.
സാർ കണ്ടിന്യൂ. ജസ്റ്റ് ആ ഒരു മൈക്ക് കുറച്ചും കൂടെ അടുത്ത് പിടിക്കും, കാരണം ഇടയ്ക്ക് ബ്രേക്ക് ആവുന്നുണ്ട്. അത് നെറ്റിന്റെ ചിലപ്പോൾ ഇഷ്യൂ ആണോ എന്ന് എനിക്കൊരു സംശയമുണ്ട്.
ചിലപ്പോൾ അതായിരിക്കും, ഇവിടെ കറണ്ട് പോയായിരുന്നു.
ഓ ശരി സാർ, ശരി സാർ, ഓക്കെ ഓക്കെ, പറഞ്ഞോളൂ സാറേ.
To find inverse of the second term, consider the second term is of the form 1 by s minus a, or a function of s minus a. So to find inverse of this expression, we have to use the concept of inverse using shifting property. So to eliminate the effect of this minus 2, we have to multiply this expression by e raised to 2. Similarly, find inverse of last term. It is also of the form f of s minus a. So to eliminate the effect of minus 2, we have to multiply the third term also by e raised to 2. It becomes e raised to 2t plus 4 into e raised to 2t into inverse of 1 by s square plus 4 into e raised to 2t into inverse of 1 by s cube. And inverse of 1 by s square and 1 by s cube, it can be found by using the concept of inverse of 1 by s raised to n. Inverse of 1 by s raised to n is e raised to n minus 1 by n minus 1. It becomes e raised to 2t plus 4 into e raised to 2t into e raised to 2 minus 1 divided by 2 minus 1 factorial plus 4 into e raised to 2t into e raised to 3 minus 1 by 3 minus 1 factorial. So reduces to e raised to 2t. Okay അല്ലേ?
ഓക്കെ സാർ. സാർ ഇപ്പൊ വീണ്ടും ഇടയ്ക്ക് ലാസ്റ്റ് പാർട്ട് കുറച്ച് ബ്രേക്ക് ആയിരുന്നു, അതുകൊണ്ട് ഞാൻ വീണ്ടും പറയുന്നത്. ചെറിയൊരു ഇഷ്യൂ ഉണ്ടെന്ന് തോന്നുന്നു എനിക്ക്.
മേ ബി ബിക്കോസ് ഓഫ് ദ നെറ്റ്വർക്ക് ഇഷ്യൂ. ഓക്കെ
സാർ, ഇപ്പൊ ബെറ്റർ ആണ്. ഓക്കെ സാർ, അപ്പൊ അടുത്ത ക്വസ്റ്റ്യനിലേക്ക് പോകാൻ എനിക്ക് സമയപരിമിതി ഉള്ളതുകൊണ്ട് നമുക്കൊരു 2 ക്വസ്റ്റ്യനും കൂടെ എന്തായാലും എടുക്കാൻ തോന്നുന്നു അല്ലേ സാർ? ഒരു അടുത്ത ക്വസ്റ്റ്യനിലേക്ക് പോവാം. ആനന്ദ് കൃഷ്ണൻ ചോദിച്ചേക്കുന്ന, ക്യാൻ യു give the concept of multiplying the e raised to 2t step of problem for last step please? ഒന്നുകൂടെ പറയാമോ?
അത് ഓൾറെഡി എക്സ്പ്ലെയിൻ ചെയ്തല്ലേ?
ഓക്കെ സാർ, എന്നാ അടുത്ത ക്വസ്റ്റ്യനിലേക്ക് പോയി. ഇപ്പൊ വീണ്ടും വന്ന ക്വസ്റ്റ്യൻ ആയിരുന്നു. നമുക്ക് ക്വസ്റ്റ്യൻ നമ്പർ 5ലേക്ക് പോവാം സാർ.
ഓക്കെ.
ക്വസ്റ്റ്യൻ നമ്പർ 5 a by s minus 1 there is no s minus 1 term in denominator of q, അതൊന്ന് പറയാമോ എന്ന് പറഞ്ഞിട്ടൊരു ക്വസ്റ്റ്യൻ ഉണ്ട്.
Can you repeat question once again?
കേൾക്കണില്ല സാർ?
ക്വസ്റ്റ്യൻ റിപ്പീറ്റ് ചെയ്യാമോ
സാർ? ഇപ്പൊ ഒട്ടും ക്ലിയർ അല്ല സാർ, ഒന്നും കേൾക്കണില്ല എനിക്ക്. അമല കേൾക്കാമോ? ഹലോ
ഹലോ, കേൾക്കുന്നുണ്ടോ?
സാർ ബ്രേക്ക് ആവുന്നുണ്ട്.
ഹലോ.
സാർ ഇപ്പൊ കേൾക്കാം സാർ.
ക്വസ്റ്റ്യൻ ഒന്നുകൂടി റിപ്പീറ്റ് ചെയ്യാമോ?
സാർ ക്വസ്റ്റ്യൻ നമ്പർ 5 ആണ്. ക്വസ്റ്റ്യൻ നമ്പർ 5 ഒന്ന് ജസ്റ്റ് ഒന്നുകൂടെ പറയാമോ എന്നുള്ളതാണ് ക്വസ്റ്റ്യൻ. കൃഷ്ണ ഐ ആണ് ചോദിച്ചേക്കുന്നത്.
ക്വസ്റ്റ്യൻ നമ്പർ 5 ഒന്നുകൂടി പറയാമോ? പാർഷ്യൽ ഫ്രാക്ഷൻ അങ്ങനെ സ്പെസിഫൈ ചെയ്തിട്ടുണ്ടോ എന്തെങ്കിലും?
ആണ് സ്പെസിഫൈ ചെയ്തേക്കുന്നത്. ഇൻ ക്വസ്റ്റ്യൻ നമ്പർ 5 ഹൗ a by s minus 1 there is no s minus 1 term in denominator of q എന്നുള്ളതാണ്.
Okay. That is the basic concept of partial fraction. If there is a repeated factor, we have to consider first degree term, then second degree term, then up to maximum degree term. Here denominator contains s minus 1 whole square. So partial fraction corresponding to s minus 1 whole square is a by s minus 1 plus b by s minus 1 whole square. And this c by s plus 2 is correspond to the second term. I think the doubt will be clear.
ഓക്കെ സർ, അത് ക്ലിയർ ആയിരിക്കും. സർ, സാറിന്റെ വീഡിയോ ഒന്ന് ജസ്റ്റ് ഒന്ന് ഓഫ് ചെയ്ത് നോക്കാമോ? അതും കുറച്ച് ഡേറ്റ കൂടുതൽ വലിക്കുന്നുണ്ട്, അതുകൊണ്ട് ചിലപ്പോൾ നമുക്ക് കുറച്ചും കൂടെ ബെറ്റർ ആവാമായിരിക്കും ഓഡിയോ.
ഓക്കെ, വീഡിയോ ഓഫ് ചെയ്തു.
ഓക്കെ സാർ, താങ്ക് യു സാർ. അപ്പൊ നമ്മൾ അടുത്ത ഒരു ലാസ്റ്റ് ഒരു ക്വസ്റ്റ്യനും കൂടെ എടുക്കാം. ഞാൻ ഭയങ്കര ഫ്രീക്വന്റ് ആയിട്ട് പിള്ളേർ ചോദിച്ചേക്കുന്ന ക്വസ്റ്റ്യൻ എന്നാണ് സെലക്ട് ചെയ്തേക്കുന്നത്. നമുക്ക് ഒരുപാട് ക്വസ്റ്റ്യൻസ് വരുന്നുണ്ട്, എല്ലാം എടുക്കാനുള്ള സമയമില്ലല്ലോ, നമുക്ക് ഓൾറെഡി 10:50 ആയി. ക്വസ്റ്റ്യൻ നമ്പർ 6 ആണ്, അത് കുറച്ച് അധികം പേര് ചോദിച്ചിട്ടുണ്ട്. Can you please explain question number 6 once more?
Okay. Consider the sixth question. First we consider the denominator. Denominator is s minus 3 into s square plus 4. Denominator is product of two terms. If denominator is product of two or more terms, first we had to apply the partial fraction technique. This is a partial fraction form. A by s minus 3 plus bs plus c by s square plus 4. Here the coefficient a, this corresponds to non-repeated first degree term s minus 3. So only a can be found by shortcut method. B and c, they are found by the general method because b and c correspond to the second degree term. So to find the value of a, we had to substitute s equal to 3, the LHS, except the factor s minus 3. So here we substitute s equal to 3, here also. So we obtain value of a equal to 3 by 13. To find b and c, we have to apply the general method. For that we have to multiply both sides by this denominator. So it becomes s equal to a into s square plus 4 plus bs plus c into s minus 3. And we expand the RHS, this RHS term. Now equate coefficients of s square. By equating coefficients of s square, get 0 equal to a plus b, which gives b equal to minus a. Value of a is 3 by 30. So we obtain b equal to minus 3 by 30. Now equating constants, we get 0 equal to 4a minus 3c. So this gives c equal to is 4 by 13. So we have the values of a, b and c. This can be substituted in equation 1. So equation 1 becomes 3 by 13 divided by s minus 3 plus minus 3 by 13 into s plus 4 by 13 divided by s square. Now we can find inverse directly. So take inverse on both sides. Here we apply the linearity property. So consider the second term. Denominator is s square plus s square. So we have two options. Numerator can be 1 or s. So we split the second term. By splitting the expression, we obtain it as inverse of 3 by 13 into inverse of 1 by s minus 3 minus 3 by 13 into inverse of s by s square plus 2 square plus 4 by 13 into inverse of s by s square plus 2 square. Inverse of s by s square plus 2 square is cos 2t. Inverse of 1 by s square plus 2 square is 1 by 2 sin 2. So this is the final answer. Any more questions?
Sir, questions under last ഒരു question കൂടെ എടുക്കാം. So only for first degree terms we can use shortcut method. അതാണ് question. ജഹർഷ M ആണ് ചോദിച്ചിരിക്കുന്നത്.
Yes. Shortcut method apply ചെയ്യാൻ പറ്റുന്നത് ഫസ്റ്റ് ഡിഗ്രി ടേമിന്റെ നോൺ റിപ്പീറ്റഡ് ഫാക്ടർ ആണെങ്കിൽ we can find all coefficients. ഫസ്റ്റ് ഡിഗ്രി
Okay,
ടേമിന്റെ റിപ്പീറ്റഡ് ഫാക്ടർ ആണെങ്കിൽ മാക്സിമം റിപ്പീറ്റ് ചെയ്യുന്ന ടേമിന്റെ കോഎഫിഷ്യന്റ് ഫൈൻഡ് ഔട്ട് ചെയ്യാൻ പറ്റും. സെക്കൻഡ് ഡിഗ്രി ഫാക്ടർ ആണെങ്കിൽ പോസിബിൾ അല്ല.
ഓക്കെ സർ, ഓക്കെ സർ. നമുക്ക് ആക്ച്വലി കുറച്ചും കൂടെ ക്വസ്റ്റ്യൻസ് ഉണ്ട്, പക്ഷേ സമയപരിമിതി കാരണം നമുക്ക് എടുക്കുന്നത് പറ്റത്തില്ല. സോ താങ്ക് യു ഓൾ ഫോർ ജോയിനിങ്. നമ്മൾ ഈ ക്വസ്റ്റ്യൻസ് സാറിന് എടുത്ത് വേറെ രീതിയിൽ എക്സ്പ്ലെയിൻ ചെയ്യാൻ പറ്റുമെന്ന് അടുത്ത സെഷനിൽ സാറിന് സമയം ഉണ്ടെങ്കിൽ എക്സ്പ്ലെയിൻ ചെയ്യാൻ പറയാമോ ചോദിക്കാം.